All right, here we are with homework 5.03, solving a system of linear equations graphically. So a system of equations is just more than one equation that we're going to solve kind of at the same time. All right, so let's take a look at this first one here. Y equals 2/3 x minus 4. Y equals negative 4/3 x plus 2. So we're looking for that one point that falls on both of these lines. We're looking for that one point that is a solution to both of these equations. All right, so we've talked a lot about different ways of graphing. For this first one, I'm going to use the slope-intercept form. Remember, it's your choice which way you want to do it, whether you use the slope-intercept or whether you make a table and graph points. I'll probably bounce back and forth and do some of these problems different ways. All right, so on the first one here, our slope is 2/3, and I know that it is 2/3 because it is the number next to the x. Slope, if we remember, is rise over run, which means I'm going to move up 2 because it's a positive 2, and to the right 3 because it's a positive 3. The y-intercept is where I start my graph. So for this first equation, my y-intercept is a negative 4. So on the y-axis, which is your up and down axis, I'm going to start down 1, 2, 3, 4, and I'm starting down because that's a negative 4. Now to move, I just go up 2 and over 3. I go up 2 and over 3, and I can also do the exact opposite where I go down 2 and back 3. So I'm going to connect my points here. I'm going to go through the end of each point and make an arrow to show that the line keeps going. And when I put my label on, I'm going to try to put it off the graph because I still have another line to graph and I don't want it to kind of get in the way of that graph. All right, so there's my first one. Y equals 2/3 x minus 4. All right, let's take a look at this next one. All right, so the slope is negative 4/3. Now, on this sheet, it's kind of hard to tell. Is the negative with a 4? Is it with a 3? It's your choice. You can put it with either, but you wouldn't want to put it on both, because if you put it on both, a negative divided by a negative is actually positive, and that would totally change your line. So I'm just going to make it a negative 4, and I'm going to put it up there with a 4 over a positive 3. So what that means is, because it's a negative 4, I'm going to be going down 4, but because it's a positive 3, I'm still going to be going to the right. So it's going to be down 4 and to the right 3. And then the y-intercept, again, which is the one without the x, is a positive 2. So that means I'm going to be starting up 2 on the y-axis. So if I go over to my graph here, I'm going to go up 1, 2. There's that right there. It's up 2. And then I'm going to go down 4 from this point that I just made. 1, 2, 3, 4, over 1, 2, 3. Then from this point, I'm going to go again, down 1, 2, 3, 4, over 1, 2, 3. And I can also do the exact opposite. I can go up 1, 2, 3, 4, and then to the left 1, 2, 3. Okay. So if I take all these and I connect my points, put the arrows on, throw a label on there. Let's see, y equals negative 4/3 x plus 2. And what I see is I have my two lines that sort of intersect here. I'm not done with the problem. All right? The whole point of making these graphs was to find the point where they intersect. So I actually have to state what this point is. Now, this is the part that kids goof up a lot, because when they're doing slope, they're doing the up and down first and the left to right second. But when you do a point, remember points, the x comes first and the y comes second, which means when we read this point, it's over 1, 2, 3, so a positive 3, and down 2, so that is 3, negative 2. Okay? So just again, you've got to keep those straight because the slope is, the y, the change in y over the change in x, how much y goes up and down versus how much x goes left to right. But when you're doing a point, you start with the x, which is the left to right, and then you move to the y, which is the up and down. So you just got to make sure that you kind of keep those two straight. All right, let's move on to the second one here. Negative x plus 3 equals y. All right, don't get thrown off just because the y is on the other side. It's still already by itself, so we're pretty much just ready to graph this one. If you want to rewrite it, we can do that. Y equals negative x plus 3. And again, you've got different ways that you can graph this. If you want to do slope in the y-intercept, you can. If you want to make a table, you can also do that. I'm going to stick with slope and y-intercept on this front side because on the back there is one where we're going to have to use a table. Okay? So let's talk about what our slope is. So usually we say the slope is the number in front of the x, but here we don't have a number, we just have a negative sign. So what's our actual slope? Well, what you have to remember is that we could always put a 1 in there. We usually don't write it, but it is there. So this is really a negative 1x. All right, so you're like, all right, there's my negative 1, but shouldn't slope be a fraction? Shouldn't I have a rise and a run? You're right. So all we need to do to turn that into a fraction is put it over 1. We can turn any integer into a fraction just by putting it over 1. 7 over 1. Negative 5 over 1. 2 over 1. Any integer we can turn into a fraction just by putting it over 1, because dividing something by 1 doesn't actually change its value. All right, so our slope for this is negative 1 over 1, which again, because this is negative, that means we're going to go down 1. And because this is positive, that means we're going to go to the right 1. So it's going to be down 1 and then to the right 1. And then our y-intercept, which is where we start our graph, is going to be a positive 3. So if we go over here, we're going to start up 1, 2, 3. So there's the y-intercept of positive 3. And then our slope tells us that we go down 1 to the right 1. Down 1 to the right 1. Down 1 to the right 1. And so on and so forth. And then we can also do the exact opposite. We can go up 1 and to the left 1, up 1 to the left 1. All right, and we'll get a whole bunch of points. Connect those points. Okay, there's that. I've got the arrows on both sides. They're going through the last point. And then I can throw my equation up on top there. Negative x plus 3 equals y. All right, so let's go on to the next one here. 4 plus 2y equals 3x. Now this one's a little different. We can't actually graph this one yet. Anytime we want to graph an equation, the first thing we need to do is get the y by itself. So let's take a look here. 4 plus 2y equals 3x. You kind of want to think of the y as having an anchor. The y is not going to move. What needs to move is this 4. We got to get rid of the 4, and we got to get rid of this 2. All right, so to move a 4 from the left to the right, we're just going to subtract 4 from both sides. We get 2y equals 3x minus 4. And then to get rid of that 2, we're just going to divide both sides by 2. And we'll get y equals 3 over 2x minus 2. So what that means is our slope is a positive 3 over 2. So that means we're going to go up 3 and over 2, because both of those are positive numbers, so we're going up and to the right. And then our y-intercept, which is the number not next to the x, is a negative 2, so that means we're going to start 2 down on the y-axis. So if we go up to our graph here, we start 2 down on the y-axis, and then we go up 1, 2, 3 over 2. Up 1, 2, 3 over 2. And we can also do the opposite. Down 1, 2, 3, and then back 2. All right. So let's connect our points here. Label our line. 4 plus 2y equals 3x. And again, we've done a lot of beautiful work, but we haven't yet answered the question. All right. The answer is, what's the solution to this system? Right there is the solution. Now let's actually write what that point is. So if you think about it, a point is an x and a y. That means the x comes first, so that's over 2, and then up 1, so 2, comma 1. All right, that would be our final answer there. That's the solution to our system. It's the one point out of the millions and millions of points out there that works for both equations. All right, so let's flip over to the back here. If drawn on the same graph, the lines with the equation y equals 3x minus 2 and y equals negative 2x plus 18 would intersect at which of the following points? All right, so this is a great time to kind of take advantage of our calculator. All right, so in our calculator, if we type in both of those equations, so 3x minus 2, let me do that again. 3x minus 2 and negative 2x plus 18. All right, and then I go to second table. This will show me all the points for both lines. So when x is 2, the first line is 4, the second line is 14. So what I can do now is I can just go and check the different multiple choices. All right, so 0.11. Well, the first line has the 0.11. But the second line has the 0.116, so that one's not going to work. All right, let's try 0.18. All right, this time the second line has the 0.018, but the first line has the 0.0 negative 2, so that's not going to work. All right, so that brings us to 410. Let's check 410. All right, so if we look at this choice here, when x is 4, the first line is 10. And the second line is 10, so there we have that single point that's going to work for both equations. And if you want to check the last one quick, 312. All right, 312, the second line is 12, but the first line is 7. So again, the only spot where both of them are the same point is 4, 10. So that would be choice 2 here. All right. I mean, the other way to do this would be to just kind of graph both and see where they intersect, but if you have a calculator, it's a quicker way to do that type of problem. Okay. Number 4 says, use your graphing calculator to set up an XY chart or an XY table for the following 2 linear functions. Then solve the system of linear equations. Check your answer on the calculator. So here's what I was saying, that this is the one that we'll make a table for. So let's see what we end up with here. All right, first thing we're going to need to do is get the y by itself. All right, so I need to move this x over, and I need to get rid of this 3. So I'm going to start by just subtracting x from both sides. I get 3y equals negative 7 minus x. Divide both sides by 3, divide both sides by 3. And I'm going to end up with y equals... Now, if I actually did this on the calculator, negative 7 divided by 3, I'm going to get a long decimal, so this is where we just kind of take advantage of our math frac, and that goes back to negative 7/3. So we've got negative 7/3 minus x over 3, or you can also think of that as like 1x over 3, so I'm just going to leave that as minus x over 3, but there is that 1 in front of there. Now, part of the reason we're going to want to use our calculator for this one is our y-intercept is a fraction. It's not an integer, so it's kind of hard to know where negative 7/3 is on this graph. I mean, we can estimate it, but it's hard to be exact. So instead, we're going to use a table so that we can get some points that are actually integers. All right, so we go to our calculator. we clear out those equations that are already in there, and we type in -7/3. Let me put that in parentheses, 7/3 minus x over 3, right? And then I can go to second table, and I get a whole list of points here. So what I'm going to do is I'm going to skip the ones that have decimals. So I'm going to start with this one here, -1, -2. So I'm going to make my XY chart, and I'm going to do -1, -2. Then I'm going to scroll down. There's 2, -3, 5, -4. Let's see, is there another negative I can do up here? Let's do -4, -1. All right, so now I have 4 points that I can graph somewhere on my grid over there. So let's go over here. Remember, x is the left to right, so that's the first point's going to be back 1 and down 2. Then we're going to go over 2, 1, 2, and down 1, 2, 3. Then we're going to go over 5, 1, 2, 3, 4, 5, and that's to the right because it's a positive 5, and then down 1, 2, 3, 4. And then we're doing a little out of order here, but if we go back to this one, it's back 4, because it's a negative, 1, 2, 3, 4, and then down 1. All right, so we've got these points here. Let's connect them. And then again, we'll throw our label on and kind of put it off to the side so it doesn't get in the way. X plus 3y equals -7. So I've got my label right there on the side, so it's not in the way of the other line. All right, so let's get started on the next one. Again, the y is not by itself, so this one we're going to have to solve. So plus 3x plus 3x. We get 2y equals 10 plus 3x. Divide by 2, divide by 2, divide by 2. Y equals 5 plus 3/2 x. All right. Now, this one I could do slope-intercept if I wanted to. My intercept is an integer, so it's easy to know where 5 is, and then it would just be up 3 over 2. But we'll do it on the calculator just so that you can see another one that uses the table. All right, so let me clear this out, and then I do 5 plus 3 divided by 2x, second graph. And again, you're going to see that I've got a whole bunch of points that I can graph here. So let's see. We'll start with -6, -4. So let's make our table over here. X, y, -6, -4. If I scroll down, I can see there's a -4, -1. -4, -1, and then there's a -2, +2, and then there's a 0, 5. Okay, so if I go over and graph this, -6, -4 is going to be back 6 and then down 4. So that's this point right here. -4, -1 is going to be back 1, 2, 3, 4, and down 1. So it looks like that's going to be our intersection point. -2, 2 is going to be back 2 and up 2. And then 0, 5 means I'm not going to move left or right at all. I'm just going to go up 5. All right, so I've got those points. I'm going to connect them. And then this would be 2y minus 3x equals 10. And I've got this intersection point, which you're going to notice is the one point that's in both of my tables, -4, -1, -4, -1. So the advantage to this approach is you don't really have to worry about reading the point and figuring out what the point is, because it's going to show up in both of your tables. And this is something that you can even do if you use slope-intercept. after you use slope-intercept to graph it, just put both equations in your calculator and find the one point that kind of matches up in both, like we did on the multiple choice up above. But our final answer would be -4, -1. Okay. All right, consider number 5. Consider the linear system of equations shown to the right. Y equals 3/2x plus 2, y equals 3/2x minus 1. Sketch a graph of this system on the axes to the right. Okay, so these both have the same slope. They both have a slope of 3/2. So in both cases, what we're going to be doing is going up 3 and over 2 because they both have the same slope. The only difference is their y-intercept. This one is going to start at 2. This one is going to start at -1. All right, so let's do the first one. I'm going to start up 2, and then I'm going to go up 3 over 2. I can also do the reverse, down 3, back 2, down 3, back 2. All right, so connect those, and this is y equals 3/2x plus 2. Now let's do the other one. It's going to be the same exact movement, only this time we're going to start down at -1. So up 1, 2, 3 over 2, up 1, 2, 3 over 2, down 1, 2, 3, and then back 2. So let's connect these. And we get y equals 3/2x minus 1. All right. So if we see here, these lines are actually never going to intersect. These lines are what we call parallel. When two lines have the same slope, those lines are going to be parallel. So will these lines intersect? No, because they have the same slope which makes them parallel. Right? Considering your answer from part B, explain why the solution set of this system is empty, contains no ordered pair. A system is this one that has no solution is called an inconsistent system. Right? The solution set is empty because they never intersect. If they don't intersect, there's no point that's going to work for both equations. Each equation has an infinite number of points that works for it, but there's no one single point that's going to work for both equations. So they never intersect, so they will never share a solution. And if they don't share a solution, there can be no answer to our system of equations. It's going to be an empty solution set because there is no intersection point. Okay? I know this was a longer homework, but I hope this video was some help. Thank you very much. Have a good day.